Okay, so we talked before about the risks that we face, about the things that we have to keep in mind when we're, how people could compromise our systems, what could happen, and how increasing software development and systems integration actually makes us more vulnerable. So, is it all bad? No, there's quite a certain number of things you could do to manage your information system security. So that's what we're going to look now to in this second part. One of the things that we, have to consider in threats and dealing with threats or risk to information system security is that we have to think about certain goals. Because making things secure doesn't exist in a vacuum or by itself. It's always a trade-off between different things. One of these things is availability. So you want to make sure that the people who need to use the systems, the legitimate users, have access to the system. So the system should be available to legitimate users and only to legitimate users. So that's one. Then integrity is making sure that people and users and other programs can only manipulate the systems that they're allowed to. So make sure that there's no unauthorized changes possible in the data and the systems. That means there's different ways of doing that, but one of them could be auditing it, making sure there's no access and so on. Then there's confidentiality. So making sure that the data does not get accessed by unauthorized people or other systems. So it's protecting the data. So with integrity, you're making sure that the data itself is consistent. With confidentiality, you're making sure that the data does not get taken out of the systems or ends up in a place where it's not supposed to be. So making sure that the data itself is safe. And with integrity, you're making sure that the data is correct and not manipulated by. And then a final step that you think about is accountability. So how do you make sure that making sure that you can trace back what has happened? If some change has been made, can you see who has made that happen? So that's accountability, and part of that is auditing, tracking changes that have been made to the system, and making sure that there is verification. In the previous example, I mentioned somebody in the salary department who was increasing their salary by themselves. So with accountability, you can make sure that you can put a system in place that every time a salary is increased, a second person has to validate that, or it has to be approved by somebody. And you want to see who has made that original change. So part of that is accountability, is making sure there is a mechanism to check things. So an example of that would be a few years ago, a Dutch, celebrity, for lack of a better word, was in the hospital, and they, in the Netherlands, there is a medical record of you on file in the hospital, and that from that person, that celebrity or that famous person, a lot of people were able to access that file and saw the medical information of that person. That was eventually leaked, that has happened. So the question is, what went wrong here? Well, if we take those criteria again, we ask ourselves, that medical record that was being accessed, what was the availability? Did legitimate users have access to it? Well, yes, they did have access to it. Was the integrity? Was the data correct in the systems? Well, we don't know, but we assume so. But now, if you look at the confidentiality, was the data confidential? No, because people who were not allowed to access it, the data itself could be viewed by people outside the system or people who did not have the right to do that. So the data itself was not confidential. And then, was it accountable? Eventually people discovered this leak, and then they could trace who were the people who checked that file, who were not supposed to, and they were able to find in the logs what has happened, and then they got reprimanded, and if they would make the mistake again, they would get fired. So the accountability of the organization was there. So that is a way that you can look at these criteria when you talk about dealing with data and data safety. This is another way of looking at these things. You have to always make this trade-off between these different factors. The availability, as we said in the beginning, can people access and use your systems? Is the data safe? Is it integer, and is it confidential? And these things are hard to balance, because you want to make the data available. You don't want to restrict your users too much, but you also want to keep it confidential. You want to make sure that the data is up to date, which means that people should be able to change it if there is a mistake. So all these trade-offs are constantly being made when it comes to information security. There's no golden rule for it other than constantly evaluating it, not just putting that policy in place once, but constantly updating it and validating it. So let's talk about how you can really look at these risks and how can you deal with these risks. Well, what you always need to do when you talk about risks is look at what vulnerabilities do we have, what are the threats that we're faced, and what could be the impact. So a risk is a vulnerability together with a threat that will result in a certain impact for you. And there's different ways you can, there's a whole field about risk management, especially in disaster management. But essentially we're saying a vulnerability is a flaw that might be exploited in your system, something that you're not prepared for, something that could lead to problems when a certain threat is there. So if you have a flaw in your software and there is a hacker, the threat and the vulnerability together pose a problem. That problem together will create an impact, a negative impact on your organization. Systems will go offline, or you need to pay money, you suffer reputation damage, and so on. So to deal with those impacts, you can put controls in place, and those controls could be to reduce the risk. So actively, reduce the vulnerabilities, install countermeasures, and so on. Accept the risk, saying, well, we can't secure against that, so we're going to accept that this is a risk, but we'll think about the impact it may have, and we're okay with accepting that risk. You can transfer the risk, which means that you can have somebody else absorb it. So think about insurance, for example. You run the risk, with your car getting into an accident, and which will mean, the vulnerability is your car, the threat is somebody else doesn't know how to drive, or you're poor at parking. Those two together will create a car accident. The impact will be that you need to pay your car to get your car repaired, and you need to pay the damage to somebody else's car. But instead of taking that risk, you transfer the risk and saying, well, if that risk of paying, I'm transferring that to the insurance company. So I'm having somebody else be responsible for me taking that risk. That's called risk transference. And then risk avoidance would be to not take the risk at all, not to run your system, to keep it offline, to not give it to customers, or stay home and don't use your car. So those are the four options. So if I summarize them again, risk reduction means you're not going to drive fast with your car, you're reducing your vulnerability, you're accepting that you'll get into an accident, you're okay with it, it's an old car. Risk transfers is, if I'm getting in an accident, it's going to cost me money, so I'm going to get insurance for it. Risk avoidance is, let's not drive at all and stay home. So how do you assess these risks? Well, let's take an example of a phone. So what are the risks if as my company, we're developing an app and for a phone? So what are the risks that we face? Well, for users, and that could be one perspective, could be that the battery is empty, which means I can't use the app. Another thing that could happen is that the phone is broken. So, I have the phone, but it's not using. And the third one would be to keep that my phone is stolen. So it's not broken, but it's stolen. My phone is lost. Somebody else has it. So you could take this table, and it will be in an assignment for the students, and start filling it. So what is the precaution I could take, and what's the chance that it happens? So, to make sure my phone doesn't die, I could keep my phone charged. And let's say there's a 25% that I'll run out of battery before the end of the day with an old phone. My phone gets broken. It doesn't happen often, but I do go for a run and it might rain. So once there's some water damage in my phone and it didn't work anymore. So let's say call that 5% chance that my phone breaks. And what could be the countermeasure I'm taking? It's a 5%. It's don't use it when it's raining. And my phone can get stolen by somebody. So what I can do with it is I can keep it in my pocket. It's linked to my smartwatch normally. So as soon as my phone and my smartwatch get too far away, I'll get a notification that something's wrong. It doesn't happen that often. So let's say there's a 5% chance of my phone getting stolen. So once we have those precautions and the percentages, what is the severity? How bad is it that it will happen? Well, my phone battery being dead is a bad thing, but it's not, the end of everything, because, at some point I'm going to be able to recharge it. I just can't use the app anymore. When my phone is broken, it's worse. It takes me longer to recover, but I could buy another phone or could borrow a phone or have a spare one. So, relatively, I would give that a 5 compared to a 3 for a dead battery. The next one will be that my phone is stolen. Well, that will be a bad thing because my data is on there. And although I have a fingerprint password for it, people might find a way around it. So my phone stolen is actually has a lot higher impact. It's more severe than my phone being broken, because if it's broken, I might be able to recover the data or get the data card out of it. When my phone is stolen, that's gone. So that's a 7. So multiplying the percentages and the severities, it will result into like what we call a risk factor. And again, it's not about the absolute numbers here. It is about relative numbers and being able to assess and compare different risks. So you will see that actually the risk factor for my phone battery dead is pretty high, because I have an old phone, the battery can die often. And so what could be my response is to get a charger. The phone is defect. What my solution would be, the chances are small, the impact is not that high, so I'll just have an old spare phone. And my phone getting stolen, will have a pretty, significant impact. So I could lock phones, lock my accounts, make sure that once my phone is gone, that I sign out of everything. And with Google, you can, register your device as stolen and get a new phone. So that gives you an idea of how you could look at this risk. So this is just looking from a user. Of course, from an organization, what you identify as risk might be different or much more extensive, but just to show you the thought process here. So once you have these risks, how do you derive a security strategy for it? So you could implement certain controls to keep your system safe and secure. There is controls to prevent things from happening. There's things to detect things from happening, and there's things to recover or correct, reduce the impact. In any case, you always want to make sure that you use the principle of least permission and least privileges. So people should only have access to the things that they need to do. So you start with 0 permissions and you start giving them more as they need to do their job, rather than giving everybody permissions and removing the permissions they don't need to have. So you should only be giving access to systems, data, and resources that you need to perform your duty, and to other things it should be restrictive. So let's take a look at these controls that are there for information security: preventive, detective, and corrective. So this is my layout of my home, and as you can see, I've installed several smart home devices in my home, including the lights, the curtains, the vacuum, heating, control, and so on. So all these devices are connected to a home system that is running here. And of course, that creates a pretty interesting target for people with intentions to misuse, because you could manipulate the lights, you could see if I'm home or not, you can manipulate the heating, and so on. So what information security could I put in place? Well, first of all, to prevent people from accessing my home, I could do something with controls, with passwords and logging in. One of the ways we do that is with encryption. And encryption is a whole extensive field study in itself. But essentially, what we do with encryption is we make 2 keys. And enable to identify if somebody is allowed to read something, you use these keys. So we make a long passphrase and we'll derive 1 public key and 1 private key. So once, in this case, Alice creates 2 keys, a public and a private key. And Bob wants to send a message to Alice. So Bob will write the message and use Alice's public key to encrypt. So that means that hello Alice will be using the key to using the formula to create a message that doesn't make sense to anyone. What's important is that these keys only work one way. Once you have encrypted it with the public key, you cannot decipher the message. For that, you need the private key. The private key tells you how to go from the encrypted message back to the original message. And that will read, hello Alice. So by using this system, Alice will know that that message is from Bob using the private key, and that only she will be able to read that message using a private key. It's a very basic example. It is, with encryption, there's a lot more possible, but essentially it's a way of verifying the identity and verifying and allowing certain people to access certain information and verifying that information. So going back to my house, there's other ways that I have. One of the ways that I have here to secure the home is two-factor authentication. So that means that in order to use the system, you need to always do two things to identify who you are. One could be a password, and the second one could be a fingerprint. It could be a PIN code together with a mobile device that's inside the house. It could be a facial recognition along with a password. So two-factor authentication means that you're using different methods to verify. You might recognize this from sites where you need to log in and you get a passcode as an SMS service. So it's using your mobile phone to verify it's you. So that's two-factor authentication. Another way that we use preventative measures is VPN, virtual private networking, which means that you can only access the systems from the outside if you make a connection to my home first. You might recognize this from work. Virtual private networking means you're registering your computer remotely on the network. So you cannot access my home from the outside only if you establish a VPN connection first. And to do that VPN connection, you need two factors. You need my password and login, and you need my mobile phone to do so. So those options are all ways to prevent people from accessing the system. That's why we call them preventive measures. Let's look at the next one, which is detective. So how do we make sure that that once people are in, that we know that they're in the system and they're doing things? Well, one of the ways to do that is to use network monitoring. I can see which devices are connected to the Wi-Fi. If there is a device my system doesn't recognize, I'll get a notification message. If you're walking around the house and nobody's supposed to be here, I'll get a notification. And how do we make sure that nobody is manipulating the software that's monitoring the house? Well, for that, I have a motion sensor next to the Raspberry Pi. You see in the picture, this is the utility closet. The Raspberry Pi is the device with the white stick sticking out. And then on top of that, in the red circle, is a motion sensor. So even if you try to physically access the server that is running the home control system, I'll get a notification. So these are all detective measures to see if somebody is manipulating the network or the systems. So they don't prevent things from happening, but they detect if things are happening. And then let's talk about corrective measures. So corrective measures are the ones that we put in place to make sure that if something happens, that we're able to still function, or to recover. And one example is, for example, it's a simple one here, the switches. So even if the system goes offline and something has happened, we can still control the lights because the hardware is still connected to the lights. It doesn't depend on the network to function. It's just an extra one. So it's a corrective measure to make sure that even if the system is offline or broken or hacked into, that at least I can still operate the lights and we don't have to, put in new wires or something. So that's a corrective measure. An alternative corrective measure is that a lot of the data in my home is backed up to the Google Cloud. So even if something, is manipulated, gets broken here, I have a backup somewhere else. Even if somebody installs ransomware on my home system, I have a backup somebody else. A bit simplified, but think about corrective measures, about things that you use when the system has been compromised. So preventive is making sure it doesn't happen. Detective is knowing that something bad is happening. Corrective is measures you put in place once something has happened to recover. And one of those ways is backups. And I'm sure you're all familiar with these. You've heard about these or you've experienced how important it is to have backups. So backup is critical for business continuity. You need to be able to restore your business and be able to recover. And Backups come in a lot of different forms. They could be on, CDs is a bit old-fashioned nowadays, external hard drive, tapes, but also the cloud could be stored somewhere else. You could have a cold backup site, and then with a cold backup site, we mean actually you have, an empty warehouse. There's all connections for power, but there's nothing there. So that means if something happens to your infrastructure, you need to move it to that new location, install it, and get things up and running. So a cold backup is something that you have the facilities, but they're not immediately ready to be used. A hot backup site means everything is ready to be used and could be, is a literal copy of your database of all the systems, which means that if one fails, you can immediately use it again. So here we're talking about really the IT hardware, and that's in data centers. And you will see data centers are systems that are really built to make sure that there is backups, there's redundancy, that if one system fails, everything will keep functioning anyway. So data centers are really designed to host servers to keep the data safe. They're redundant. They're often connected to the top level data centers are connected to even 2 different power stations. They have backup systems, diesel generators. So when you talk about securing, building a data center, keeping your data safe physically, you have to think about site selection. How do you make sure that people don't enter the building? So physical access restriction. Make sure that people don't break in, that the power keeps functioning, be protected. You don't put it in a hazardous area where earthquakes could happen, and so on. So that's keeping the data center itself safe. But nowadays, there's even, data centers around the world that are all connected and replicating. We call that, it's the cloud, which means actually you don't have to worry about anymore. That's what you see a lot of companies do these days, is that they're not the ones storing the data and responsible, but they're actually using the cloud. And the cloud is not one data center, but it's a network of data centers that are constantly copying data between each other and keeping backups. So even if you have a failure in one data center, it doesn't, or 2 or 3, there's backups across the world from all the data. So that's also called the cloud. And here in this picture, you see an example of the Google Compute Engine cloud that's connected across 6 different regions around the world, 18 zones, and 100 points data centers that are all data centers interacting with each other. So even if one plane crashes and on another one something happens, the data will still be there and available. Might not be as fast as it used to be, but your data is still safe. And those data centers are connected with each other through massive internet cables or backbones. And this is an example of a Dutch company, KPN. This is their network operations center. And you can see this is an entire floor dedicated to monitoring the status of their network. Think about detection, again, preventive, detective, and corrective. So this is a whole floor working to maintain the integrity of the data centers and the networks here in the Netherlands and their companies around the world. So you can see that, that is a data internet infrastructure is actually a critical part, critical and vital infrastructure these days that's being very well monitored and kept online. So what is important that even if you make backups, even if you put all these measures in place, as we said in the very beginning, it's not just the technology, it is the people, it's your organization. So not only can you prevent things from happening by putting technical measures in place, it is also about policies, training, awareness of your users. That means that you have to have some policies in place how to handle secure information. How do you deal with confidential information? How do you deal with security? What backup policies do you use? How do you manage accounts? How do you handle if something goes wrong in an incident? What is the plan if everything fails? So a disaster recovery plan. So it's not just putting technical measures in place. You have to approach this as a business and think about it. Think about the scenarios. What could happen here? What do we expect our users to do? What behavior don't we want the users to exhibit? How do we make that happen? Either through training or through tools or some other way. And that gets to the point of saying, well, even if all these measures are in place, think again about the risk matrix. And you think I have all these measures in place, but there's still a small chance that something will happen, that something catastrophic will happen, even if you don't imagine it. And this is what happened at Maastricht University. This is what happens all the time when you see a big disaster or IT incident in the news, is that sure, these people had measures in place, but something happened. So it is important to think about how do you deal with those disasters. And there's two components to that. One is how do you recover from it, and one is how do you make sure your business keeps running. So think about if IT fails, how do we still provide our services? How can we still answer the questions from our customers? How do people still be able to order with us? Do we do it by phones? Do we have a backup? Can we go to a different supplier? Or do we accept that we're offline and we'll be back in 3 days? Something like that. That includes communication to your customers. What do you tell them? How do you report to them? How do you inform them? Through social media and so on. So think about how you continue your business. At the same time, the other part of the plan is thinking about how can you recover? How do you start working to put your systems back? So that is, of course, using your backup, getting IT stuff ready to start building the systems again, and so on. So it's two parts. It's making sure your business keeps running, and it is recovering your systems at the same time. And there's a lot of questions if you start creating these plans. Think about scenarios. What could happen? What should we do to prepare the backups? Who decides what when something like this happens? What software do we need? What kind of staff do we need to be able to handle such an event? Can we outsource it? Do we need to get external people in? Which things should we recover first? And who else could help us? So even though it's unlikely for some plan, but think about these plans. Again, not because there might be a technical failure, it could be a human error as well. So that brings me to this last slide that I think represents a lot of the things, summarizes things quite well. It's called the Swiss cheese model, and you can see like these different slices with holes in it. And no single security measure, whether it's a backup, whether it's put firewalls in place, whether you put training in place, all these things, they're great, but they won't be perfect. There will always be holes in it, even if it's because people use it, because you have disgruntled employees, because somebody made a quick mistake somewhere in the software, you put something in place that isn't completely secure. That is fine. The problems arise that when a risk manifests and is able to go through each and every layer because the holes line up, as you can see here with the red arrow. So the Swiss cheese model says no single security layer will be perfect, which is fine as long as you make sure that the holes in the security layers don't line up in such a way. But you can imagine that this is very hard to assess because these holes can be tiny, you might not know them, the security layers can get pretty big. So that's why it's important to think about this risk model and at the same time think about, okay, what if that arrow makes it all the way through, our systems go offline, what should we do next? Okay, thank you very much for watching and see you in the next lecture.